Hello students, welcome to Naran PU College online classes. So in the last video, we have discussed about the preparation of nitric acid. So there is a small mistake in that Oswald process, and the step 1 I have mentioned catalytic oxidation of ammonia by atmospheric oxygen. You have to write there. I have written air, so sorry for that. It is small mistake. So you have to write step 1 catalytic oxidation of ammonia by atmospheric oxygen, that is not air. Clear, mates? So next one here we will discuss about the preparations are over. One is laboratory preparation and another one is large scale preparation of HNO3 by Oswald process. Very important, that Oswald process for the 3 marks question. Clear? Now we will discuss about the structure of HNO3. Structure of HNO3. Clear? So we have already discussed about the structure of HNO3. So what is that one? You already know that H, because in oxo acids of nitrogen we have discussed. Clear? Again we will discuss here oxygen and OH, and you know that there will be a double bond, and here there is a single bond with the oxygen, and here positive charge. If nitrogen is forming more than 3 bonds, nitrogen has to get positive charge. Oxygen has to form how many bonds here? 2 bonds. If oxygen is forming more than 2 bonds, oxygen acquires positive charge. If oxygen forms less than 2 bonds, oxygen acquires the negative charge. Clear? So here you see oxygen is forming 2 bonds, so that's why no charge here. Oxygen is forming only 1 bond, so that's why oxygen should get the negative charge. If oxygen forms more than 2 bonds, oxygen should get a positive charge. Clear? That is, nitrogen actually should form 3 bonds, but nitrogen is forming how many bonds here? 4. 4 means nitrogen should get the positive charge, because that 4th bond is due to the donation of lone pair of electrons of nitrogen, so that's why positive charge you will get. Clear? So this is the structure, or you can write this is, if you remove the charges, you can simply write the dative bond. Clear? So this is the structure of what it is HNO3, and also it involves in the resonance. Why? Because you see here double bond, negative charge separated by which one? Single bond. So they are in conjugation. When they are in conjugation, they involved in the what it is resonance. So this bond will come here, and this bond electrons will go towards oxygen. So what you will get here? You will get the compound is HO, and here N positive charge, and this one will converted into single bond because this oxygen is gaining electron, negative charge. So this you will get double bond O. Clear here? If you see what is the hybridization of central element here? What is the central atom here? Nitrogen. Clear, mates? Nitrogen, mostly we will consider less electronegative atom as a central atom. So that's why nitrogen is a central atom for this. So what is the hybridization of, this is the structure. What is the hybridization? What is the hybridization of nitrogen? Central atom here, nitrogen. You already know. So how many bonds here nitrogen is forming? Clear? In this case, 1, 2, 3, and 3 bond pairs are there. 3 bond pairs, and this is pi bond is there. Pi bond we never considered in the hybridization. So that's why how many sigma bonds are there here? 1, 2, and 3. 1 is pi bond. Clear? So that's why 3 sigma bonds means what is the hybridization? sp2. Clear? 3 plus 0. Clear? There is lone pair here. I already mentioned what is the hybridization. The number of bond pairs plus number of lone pairs. Bond pairs means what it means? Sigma bond pair means sigma electrons. So here this is 1 bond pair. This is 1 bond pair means 2 electrons here. Pair, and here pair, and this is also 3. And 3 we never consider pi bond here in the hybridization. And 3 bond pairs here, and lone pair. Is nitrogen having any lone pair here? No. So that's why 0. 3 plus 0 means what it is? You know 3 plus 0 means 3, so it is a hybridization is sp2. So what is the hybridization of nitrogen in HNO3 means what it is here? sp2 hybridization. sp2 hybridization means what is the structure of this one? Structure of HNO3 is a planar, trigonal planar. This is the structure. Clear ma? So this is about the what it is ma here, structure of HNO3 nitric acid. All atoms, you know, OH and double bond O and O minus, and here also OH, O minus and double bond O and nitrogen, all are present on the plane only. Clear ma? So this is about the structure of HNO3. Now structure is over. Next one is physical properties. Next one what it is ma here, put the heading physical properties. Clear? Physical properties. Yeah. What is the first one? First point here is, you know that pure nitric acid is a, you know, colorless fuming liquid. It is a liquid. HNO3 is a liquid. Clear ma? So if you take pure HNO3, it is a colorless and also fuming. If you open the lid of concentrate, if you take in the laboratory also and open the lid of HNO3 bottle, and you will get the fumes. Clear ma? So that's why it is, you know, HNO3, pure HNO3, pure nitric acid is a colorless, what it is ma here, fuming liquid, colorless fuming liquid. This is the first point. Clear? And the second one, impure HNO3. Clear ma? Impure nitric acid. Impure nitric acid is a yellow color. What it is ma here? Yellow in color. Clear? So impure means most of the nitrogen oxides are present as a impurities in the HNO3, and due to that impurities, and it will be in which color ma? Yellow in color. Clear ma? So that is the and the second point of this. And pure nitric acid here freezes, pure HNO3 freezes at 231.6 Kelvin, boils at 355.6 Kelvin. Clear ma? So this is the, and the temperature means freezing point and boiling point of what it is ma here, HNO3. And you know that here laboratory grade HNO3, clear ma, is a constant boiling mixture. Constant boiling mixture means what is ma? Azeotrope. Clear ma? So, and what is that constant boiling mixture here is, you know that laboratory grade HNO3 nitric acid is a, you know, constant boiling mixture. Constant boiling mixture means what it is ma here, 68% of the HNO3 and plus 32% of water. So at this percentage, and you know that HNO3 is a constant boiling mixture, means we can say it is a azeotrope. Clear ma? And this is about the fourth point. Clear ma? So one is, and it will have, you know, gravity is there. What is the gravity value here is, it has a specific gravity of 1.504. And next point is, it has specific gravity value is specific gravity 1.504. Clear ma? So these are about the physical properties of which one ma here, physical properties of HNO3. Clear? See, the first we have discussed structure and physical properties, and here pure HNO3 is a colorless fuming liquid, and impure nitric acid is a yellow in color. Clear ma? Yellow in color means you already know that. And why it is yellow in color? Because of impurity. Impurities means what? Mainly impurities are nitrogen oxides are present as impurities in HNO3, and pure HNO3 freezes at 231.6 Kelvin and boils at 355.6 Kelvin. And laboratory grade HNO3, what we will use in the laboratory, that laboratory, you know, grade HNO3 is a constant boiling mixture, that is azeotrope, and forms at what? 68% of HNO3 and 32% of water, and it has a specific gravity, that value is 1.504. and this is about the structure and physical properties of HNO3. Next one is physical properties we have completed, and the next one is chemical properties. Clear? As usual, how we are discussing in the previous also. First we will discuss about the preparations, if structure is there, structure, and after then physical properties, chemical properties, and uses. Clear? So chemical properties, the first one is here acidic nature. Put the first heading acidic nature. Acidic nature. Clear? So you know that, and nitric acid or HNO3 is a strong acid. It is a what? It is a strong acid, and in the aqueous solution it ionizes into the ions. It gives the H plus ion. You know that acid means what it is? It should give the H plus ion. So if you add HNO3 into the water, and it gives the H plus ions to the water, into the water. Clear? So that is, you know that HNO3 is a strong, it is strong acid. It is a strong acid. Clear? So when it dissolves into the water, you know that HNO3 and dissolve into the water, it should give which ions? H plus ions, because acid gives the H plus ions. That H plus ions will be taken by which one? Water. So what you will get here? You will get the NO3 minus and plus H3O plus, but that H plus will be taken by which one? H2O. So being a acid, it will react with the metal oxides and metal hydroxides, carbonates and bicarbonates, because those all are, you know, basic. Metal, you know that all metal oxides are basic in nature. Non-metal oxides are mainly acidic in nature. So that's why being a acid, it will react with the, you know, it will react with the some bases, like if you take calcium oxide. Clear? And if I take here calcium oxide, then what the compound you will get? You will get the compound is calcium nitrate, salt. This is like acid and this is like base. It is a acid and it is a base. You will get what it is? Salt plus water, like. So that's why calcium nitrate. What is the calcium nitrate formula? CaNO3 2 times plus what you will get here? You will get the H2. Clear? So NO3 2 times are there, so I have to take here 2 moles, then H, and here 2 hydrogens are there, and here also 2 hydrogens. Salt plus water, calcium nitrate plus water. In the same way, if I take here HNO3, when it reacted with the sodium bicarbonate, sodium what it is? Bicarbonate. Clear? Then what you will get? You will get the sodium nitrate. What is the sodium nitrate formula? Salt, NaNO3 plus sodium nitrate. What is this one? Sodium nitrate. Sodium nitrate. Clear? Plus, you know that carbon dioxide, carbonate is there. Definitely it releases the carbon dioxide, and it releases the carbon dioxide gas. Plus 1 oxygen, and here 2 hydrogens are there, will be removed as a water. Clear? And the same way, if I take here HNO3 plus Na2CO3, sodium bicarbonate, this is sodium bicarbonate, this is sodium carbonate, then what you will get? Same Na2CO3, you know Na2CO3 is there, and you will get NaNO3 sodium nitrite, NaNO3 plus CO2 plus H2O, but here 2 Na is there, so I have to take here 2 moles, then I will get the 2 Na, and here CO2 plus what you will get? H2O. So this is about the, how many hydrogens are there? 2 hydrogens. So here H2O. This is about the acidic nature of, you know, HNO3 is a strong acid. It gives the H plus ions very easily. So that's why, and in the solution it is in the form of nitrate ion and gives the H plus ions to the, being a acid, it will react with some bases like calcium hydroxide or calcium oxide and the sodium bicarbonates and carbonates, and gives the respective salts and water. Clear? This is about the first one, acidic nature of the HNO3. Clear ma? And next one is, second property is, oxidizing power. Second one, what it is ma here? Oxidation or oxidizing agent. Clear ma? So very important, this is oxidizing agent. Clear ma? So HNO3 is a very powerful, or you can say very strong oxidizing agent, since it gives nascent oxygens in concentrated as well as dilute form. Concentrated as well as which form? Dilute form. Clear? So it is a very strong oxidizing agent. Why? Because it gives the nascent oxygens in the concentrated as well as dilute form. So what is that reaction that we will discuss? Suppose I will take here HNO3, clear ma? And take here concentrated HNO3, clear ma? Take the concentrated HNO3, and now when it is heated, when it acts as oxidizing agent, and it will be converted into NO2 plus H2O plus, it gives the oxygens. Oxygens means, here there will be a nascent oxygens. Clear ma? See now, HNO3 is there, and here H2O means how many moles I have to take? 2 moles here. Take the 2 moles, then I will get the 2 NO2. Clear ma? So how many oxygens are there here? 6. And here 4 plus 1, 5. 5 means 1 nascent oxygen. This is clear ma? So this is a nascent oxygen. So this oxygen is the responsible for the oxidizing power of the HNO3. Clear ma? So you know that oxidizing agent, what it will do? It oxidizes other substance. How it oxidizes other substance? By providing the nascent oxygens to others. Clear ma? So that is the, that's why HNO3 is act as a oxidizing agent. If suppose it gives nascent hydrogens, then it acts as a reducing agent. It acts as which one? Reducing agent. So it is giving what it is? Oxygens. In the same way, if I take here dilute HNO3, take the dilute HNO3, here concentrated, here what it is? Dilute also what it is? You see, very important, when it acts as oxidizing agent, it oxidizes other substance, it undergoes reduction. What is the oxidation number of nitrogen here? HNO3, 5, and here what is the oxidation state? And 4. When it acts as an oxidizing agent, it oxidizes other substance and it undergoes reduction. Reduction means what? HNO3 undergo reduction to NO2. That is important. Means whenever we use the concentrate HNO3 as an oxidizing agent, one of the product should be NO2. Clear matters? And next one, in the same way, dilute HNO3. When dilute HNO3, when it acts as an oxidizing agent, it undergo reduction to NO, nitric oxide, and gives the H2O plus. Here also it gives the what it is? Nascent oxygens. Clear ma here? See now here, what is the balancing equation? And here 2 moles and 2 hydrogens are there. 2 hydrogens. How many oxygens are there? 6. But here 2 plus 1, 3. So that's why what it is? It is giving 3 nascent oxygens. Clear ma? And these 3 nascent oxygens are the responsible for the oxidizing property of the HNO3. When it acts as an oxidizing agent, it should undergo reduction. So how to undergo reduction? It is a 5 and it will be converted into NO. See, 5 to 2 means what it is? It is undergoing reduction. Oxidizing agent undergo reduction. Clear? When dilute HNO3 is act as a oxidizing agent, then one of the product should be NO. But some special cases are there, and remaining all cases, and what is the product here? NO should be the product. Clear? So this is the responsible, these nascent oxygens are the responsible for the oxidizing property of the concentrate HNO3 and dilute HNO3. So that's why HNO3 act as a very powerful oxidizing agent. Clear ma here? Now, and it is oxidizes many non-metals and metalloids and metals also. Clear ma? So we will discuss one by one how it oxidizes, you know, non-metal, metalloids and compounds, then finally metals. Clear ma? So you understand or not? You have to remember and this equation. Clear? Now first one I will discuss here, oxidation of non-metals. Oxidation of which one ma here? Non-metals. Clear? Oxidation of non-metals. Clear? So non-metals, you know that dilute HNO3 has no action on non-metals. Only concentrated HNO3, it is oxidizes the non-metals and metalloids. Clear ma? So I will write that one point here. Clear? So dilute HNO3 has no action on non-metals. No action on which one here? Non-metals. Clear? So next one. And concentrate HNO3, it only oxidizes. Clear? So very important point here. And HNO3 oxidizes non-metals like carbon, sulfur, phosphorus, iodine. Clear? And also, you know, metalloids like arsenic, antimony to respective what it is oxo acids. This is point very important. Clear ma? So HNO3, concentrate HNO3 oxidizes, clear ma? Non-metals like what it is ma here? Carbon, clear ma? Sulfur, clear, acid it will be, and phosphorus and iodine, and you know that here metalloids like you know arsenic, antimony into respective oxo acids, and while HNO3 is reduced to which one ma? NO2. While in this process and HNO3 reduced to NO2, because whenever concentrate HNO3 is act as an oxidizing agent, it should reduce it to which one ma? NO2. And this we will discuss here one by one what are the reactions. Clear ma? So this is about the oxidizing. Clear ma? So I mentioned here oxidizing, how HNO3 act as a powerful oxidizing agent, and we are discussing about the, you know, oxidation of non-metals, and mostly non-metals and metalloids are oxidized by HNO3 and gives respective oxo acids. And first one here, carbon oxidizes to carbon dioxide. Right here, carbon oxidizes to carbon dioxide. Clear ma? So this is the first one. Carbon is oxidized to carbon dioxide. Carbon is oxidized to carbon dioxide. So how the reaction? Clear ma? See first one, carbon plus HNO3. Which HNO3 we are taking here? Concentrate. Dilute HNO3 is not, only concentrate. Then what the product you will get? Carbon is oxidized to carbon dioxide. Carbon dioxide means what is the formula? CO2. If you use concentrate HNO3 as a oxidizing agent, what is the one of the product? One of the product should be NO2 plus H2O. I mentioned here. Concentrate HNO3 is there, concentrate HNO3, clear ma? So it will be oxidized, it oxidizes other substance, it undergo reduction to NO2 plus H2O plus what it is ma? Nascent oxygen here, clear ma? So that's why what is the another product here? HNO3 act as an oxidizing agent means it has to reduce to NO2 plus what it gives ma? H2O. Carbon is, actually it is carbonic acid, CO2 plus H2O combines and gives the carbonic acid, but it is easily undergo dissociation, so that's why we will write separately. CO2 and H2O. Clear? That's why I mentioned here directly oxo acid. H2CO3 is a oxo acid. Clear? But we have written here CO2 and H2O separately. And balance the equation. Clear? Ma? Balancing equation is very easy here. You have to follow oxidation number method. Clear? Ma? So just I will discuss. Carbon. What is the carbon oxidation state here? 0. What is the carbon oxidation state here? +4. Oxidation state of nitrogen is +5. Oxidation state of nitrogen is +4 here. Clear? Ma? So what it is? 0 to 4. How many units increased here? 4 units. And 5 to and here 4. How many units increased here? 1. You know that. How many units decreased here? 1. Increased here? 4. And increasing oxidation number and decreasing oxidation number should be equal. You have to make it equal. Here 4 is there. So that's why I have to multiply this equation with the what it is? 4. Then here 4 and 4 means HNO3 and NO2 should be multiplied with the which number? 4. Clear? Ma? And here no need to multiply this C and CO2 because it is 4 and it is 1. So that's why you have to multiply. Then what you will get? You see, you will get the balanced equation here directly. You can write. Clear? Ma? So every time I will not write this is. Clear? Ma? So you have to multiply this one with the what it is? 4. If it is 4, how many NO2s will be there? Because here nitrogen's 4 and I have to multiply this one 4. And how many hydrogens are there? 4. So I have to multiply this one with the 2. This is the balanced equation. Clear? Ma? And next one, sulfur is oxidized to sulfuric acid. Second one, what it is ma here? Sulfur. Sulfur is oxidized to. Sulfur is oxidized to sulfuric acid. What is the sulfuric acid ma? H2SO4. Clear? Ma? Same. Right here S8. Sulfur means it is available in the form of S8. And here HNO3 is giving rise to. It is oxidized to which one ma? Sulfuric acid. What is the sulfuric acid? H2SO4 plus what is the another product? You already know. One is the NO2 because when it HNO3 oxidizes the sulfur to sulfuric acid and it reduced to NO2 plus what you will get here? H2O. Clear? Same balancing equation. Easy. Same like here. Oxidation number method. 0 and here what it is ma? +6. 0 to +6 means how much it is ma? See 6 units for 1 sulfur. But how many sulfurs are there? 8. So how many units here? 48. Clear ma? And here you know that it is a +5 and it is a +4. How many units decreased here? 1 unit decreased here. And here how many units increased? 48. So that's why I have to multiply HNO3 and NO2 with the what is the number ma? 48. Then both will equal same. 48 units increased and 48 units decreased oxidation number. So that's why I have to multiply HNO3 and NO2 by which one ma? By 48. So that's why balancing is easy. 48. Clear ma? 48 means how many sulfur atoms are there here? 8. So here 1. So that's why you have to multiply this one with the 8. How many nitrogens are there? 48 nitrogens are there. So that's why here I have to write 48. Clearly I will write 48 NO2. Clear ma? Plus how many hydrogens are there? 48. But how many are there here already? 16. 48 minus 16. How much you will get ma? 32. 32 means here water is there. 16 you have to write. 16 into 2, 32. This is the balanced equation. Clear ma? Sulfur is oxidized to sulfuric acid. Carbon is oxidized to carbonic acid, that is CO2. Plus H2O, we will call carbonic acid. Clear ma? Next one. Phosphorus is oxidized to. Phosphorus is oxidized to. Phosphorus is oxidized to phosphoric acid. Phosphoric acid. What is the formula of phosphoric acid ma? H3PO4. Clear ma? See right here, phosphoric acid means phosphorus is available in the form of P4. P4 plus HNO3 is giving rise to, what is the phosphorus is oxidized to, oxidized by HNO3 to phosphoric acid. What is the phosphoric acid formula? H3PO4. What are the another products? You already know. One is NO2 and another one is what it is ma? H2O. How to balance also you already know. So here 0 and here what it is ma? Plus 5. Clear ma? 0 to 5. How many units increased ma here? There are 5 units, but for each phosphorus increased is 5 units. But how many phosphorus are there? 4. So 4 into 5, 20. 4 into 5, how much ma here? 20. So that's why you have to multiply. Here how much it is? It is a 5. It is 4. Only 1 unit here. Here how many units? 20 units. So that's why you have to multiply HNO3 and NO2 by which one ma? 20. That is. So that's why here balancing is easy. Clear? If you know oxidation number method. So multiply this one with the 20. So how many phosphorus are there? 4. But here 1. Multiply this one with the 4. So next one, nitrogens, how many are there? 20. Multiply this one with the 20. How many hydrogens are there? 20. But here already 12 are there. So that's why. And here 4 and 20. This is clear ma? So that is phosphorus is oxidized to phosphoric acid. And fourth one, iodine is oxidized to, iodine is oxidized. Iodine is oxidized to iodic acid. Iodic acid. What is the iodic acid formula? HiO3. Clear ma? Same balancing how to write here. Same you have to do the balancing. Iodine means what is the formula ma? I2 plus HNO3. So HNO3 it oxidizes the iodine into iodic acid and itself it undergo reduction to NO2 plus what it is ma here? H2O. Clear ma? Balance here. You know always here 1 unit increase. Nitrogen here 2, nitrogen here. How much unit increased here? It is plus 5 and it is plus 4. 1 unit increase. And here 0. And if you calculate here, you will get the HiO3 5 here. Clear ma? So 0 to 5 means how many units increased ma? 0 to 5. 5 units increased. But how many for 1 iodine? But here how many? 2. So that's why into 10. Here 10 means into 2. How much ma here? 10. Means 10 units oxidation number increased here, but here 1 unit oxidation number decreases. So that's why I have to multiply this equation to the 10. So that's why multiply this is with the 10 and here you will get the what it is ma? 10. But how many iodines are there? 2. So multiply this one with the 2 HiO3 and 10 hydrogens are there, already 2 are here. So that's why 4. So this is the what it is ma? Balancing equation. In the same way, clear ma? Arsenic is oxidized to, you know, As, arsenic, As4 also, because phosphorus, arsenic they are in the form of P4 As4, but here with the 4 I have mentioned, I will take simply arsenic. Arsenic is a, you know, metalloid. Clear ma? So and treated this one with the HNO3 means here you write fifth one arsenic. Fifth one, arsenic is oxidized to, arsenic is oxidized to arsenic acid. Clear ma? So same here, what is the arsenic? I will write only simple As. Clear ma? So here HNO3 and what is the product here? Arsenic acid. What is the arsenic acid formula? H3AsO4. Like H3PO4 is there, H3AsO4. So what you will ma? It is HNO3 is converted into H3AsO4 plus same as usual NO2 plus what it is ma? H2O. See here, what is the oxidation state? 0 and here plus 5. From As to, yes, 0 to 5. How many units increased ma here? 5 units increased. Because here only 1 atom is there. So 5 units. And you know that here plus 5 and here plus 4. How many units increased here? 1 unit decreased and here 5 units increased. So that's why this equation I have to multiply this one and this one. Means I have to multiply with the 5. So multiply this one with the 5. Clear ma? If it is 5 and you know how many nitrogens are there? 5. So I have to multiply this one with the 5. Clear ma? So next one, arsenic 1, here also 1. How many hydrogens are there? You know 5 and here 3 and here 2. This is the balanced equation. Clear ma? So this is about what it is ma? How HNO3 oxidizes non-metals and metalloids. Simple, HNO3, only concentrate HNO3. Dilute HNO3 has no effect on the non-metals and metalloids. and concentrate HNO3 oxidizes all the non-metals and metalloids into their respective oxo acids. Here carbon oxidized to carbonic acid. Carbonic acid means what it is? H2CO3. One water molecule if you add, you will get the H2CO3 plus H2O you will get. But it is unstable, so that's why CO2 and H2O we have written. Carbon is oxidized to carbonic acid or carbon dioxide. Sulfur is oxidized to sulfuric acid. Phosphorus is oxidized to phosphoric acid. Iodine is oxidized to iodic acid. And arsenic is oxidized to arsenic acid. Clear ma? This is about the oxidation of non-metals. Next one is oxidation of compounds. Second one in the oxidation, second one is oxidation of compounds. Oxidation of compounds. Clear no? And how HNO3 oxidizes some compounds. Clear no? The simple here, both the dilute HNO3 and concentrate HNO3 both can oxidize some compounds. Clear? And what are those? First one is H2S. It oxidizes H2S into sulfur. Clear ma? See, you know what is the oxidation number of the sulfur here? -2. And here what it is? 0. -2 to 0 means oxidation number increasing. Increasing oxidation number means what we will call? Oxidation means this compound undergo oxidation in presence of which one? HNO3. Means HNO3 oxidizes the H2S into sulfur. Clear ma? So that is this is compound. H2S is a compound. Clear ma? So how it oxidizes? Clear ma? And H2S and take here HNO3. I mentioned here both the dilute and concentrate. If I take here concentrate, say the products here, H2S is oxidized to sulfur. Clear ma? And concentrate HNO3 means it is reduced to NO2 plus also gives what it is H2O. That is balance here. Same I mentioned already how to balance it here. Clear ma? You know that it is a -2, it is a 0. You know it is always +5 and +4. 1 unit decrease only. From here to here, what is how many units decreased? HNO3 to NO2 1 unit decrease. And but here how many units increased here? 2 units increased. Clear ma? So that's why I have to multiply this one with the 2 and both will equal. Means I have to multiply this one with the 2. That is the concept. Clear ma? So you have done already. This is in the first year redox reaction oxidation number method. Clear? So that's why. And you see now balance H2S and convert into sulfur. How many? 2 NO2 N nitrogens are 2. So multiply this one with the 2. How many hydrogens? 2 and 2 4. 4 means it is this. This is with the concentrate HNO3. Concentrate HNO3 oxidizes the H2S into sulfur. Both dilute HNO3 also it oxidizes the hydrogen sulfide into sulfur. Clear ma? So that also we will see. And H2S plus HNO3. Clear ma? Now previous what I have taken here concentrated. Now what I will take here dilute. Same. H2S is oxidized to sulfur. Clear ma? But HNO3 is a oxidizing agent. It oxidizes H2S into sulfur and it will reduce to which one? NO. I have already given. Plus what it is here? H2O. Concentrate HNO3 NO2. Dilute HNO3 NO. That is. Clear ma? So that's why balance now. Balancing means here how much increase ma here? Here 2 units increase, but here what it is? 5 and here you know 2. How many units decreased here? 3 units. So make equal both the increasing oxidation number and decreasing oxidation number. It has to multiply with the 3, it has to multiply with the 2. Then it will be 6 and 6. Means and H2S and S should be multiplied by the 3 and HNO3 NO should be multiplied by the 2. Means I have to multiply this one with the 3 and I have to multiply this one with the 2. Clear ma? So then you will get automatically, we will see here oxidation numbers. Clear ma? So now see here 3 H2S means here there will be a 3 sulfur. 2 means I have to multiply this one with the 2. Clear ma? Now how many hydrogens are there? 6 plus 2 8. So that's why it is 4. See? Clear ma? Same how this HNO3 concentrate HNO3 oxidizes, dilute HNO3 also oxidizes in the same way, but products will different here. Sulfur but NO2 here and NO here. That is Clear my dears? And in the same way, take the another one compound. H2S is oxidized to sulfur, and next one is, you know that here, sulfuric acid. Sulfur dioxide is oxidized to sulfuric acid by using which one? By using what it is, concentrate HNO3 and dilute HNO3 also. Same, write the equation here, SO2 plus HNO3. HNO3 means what you have to take here? Take the concentrate HNO3. Then what the product you will get? You will get the product is here H2SO4. It oxidizes sulfur dioxide to sulfuric acid. HNO3 means what it is? It will be converted into NO2. But H2O will not come because this hydrogen will be converted into H2SO4. Because this hydrogen is used in the formation of H2SO4. Water will not come there. Clear? Balance here reaction, same here, you know, plus 4, and here there is a plus 6. Clear? And here plus 5 and plus 4. 1 unit decrease here and 2 units increased here. So that's why I have to multiply this one with the 2. And 2, and here HNO3 means I have to multiply this one with the 2. 2 nitrogens are there, 2 nitrogen. Clear? See now balancing equation, and 2 H2O, and here H2 is there. There will be a H2. SO2 and 6 oxygens are there here, and here 4 plus, you know, 6 plus 2, 8. Here also 4 plus 4, 8. This is the balancing equation. Clear? In the same way, if I take here sulfur and HNO3, clear? And you will get here H2SO4, but instead of NO2, what you will get? NO. Balance here also. Clear? So what is the reaction here? Plus 4, and here plus 6. And you know this is a plus 3, and sorry, this is a plus 5, and here there is a plus 2. Means here increasing is 2, decreasing is 3. Means I have to multiply this one with the 3 and this one with the 2. That is clear? So now what you will get, you see, 3 sulfuric acid means I have to multiply this one with the 3, and the NO2 2 are there, NO2. So now oxygens balance, and 6, and here 6, total how much? 12, and here 3 plus 12 plus 2, 14. So that's why I have to add here water molecule. Clear? So water molecule if I add, then it will be balanced. Here 2 hydrogens are there, here 6 hydrogens are there, here 2, means here I have to take the 2 water molecule. And this is how this oxidation means HNO3, both the dilute HNO3 and concentrate HNO3 oxidizes the compounds. These are H2S are the compounds. Clear? So another one is there here, and last one, and that is it oxidizes FeSO4 into Fe2SO4 thrice. This is another one. Clear? So these are important. Why? Because in the competitive examination also they will ask, when H2S is concentrated with the, means oxidized by the concentrate HNO3, and it gives the sulfur plus H2 and dash. Clear? So it is a NO2, like that you have to write. Clear? So first of all, what it is here? FeSO4 and plus HNO3. HNO3 means what I can write here? Concentrate HNO3 can I take or not? Yes, you can take the concentrate HNO3. And now, and you know always FeSO4 it should convert it into Fe2SO4 means the medium you have to take always sulfuric acid. Why? Because here sulfurs SO4s are there, here 1, here 3. So you have to add H2SO4 to balance the SO4 units, SO4 molecules. And also always this reaction takes place in presence of acidic medium. Clear? Then what the compound you will get? You will get the compound is Fe2SO4 thrice. Clear? Plus what you will get here? NO2 you will get plus H2O. NO2 plus H2O. Clear? So same way you have to balance here. Here how many ions are there? 2, and you have to multiply this one with the 2. Clear? So now balance here. This is plus 2 and this is a plus 3, and you know this is a plus 4, this is plus 5, and this is what it is, plus 4. Here increasing is 1 unit, but 2 ions are there. Increasing is 2 units here, but increasing is 1 unit here. So that's why I have to multiply this one with the 2. So if I multiply this one with the 2, I have to multiply this one with also 2. Clear? Then balance here, remaining sulfate ions are there. FeSO4, SO4s 2 are there, and here 1. Total how many are there here? 2 plus 1, 3, and here Fe Fe2SO4 thrice. Here how many are there? 3 are there. Clear ma? And now this is balanced automatically. Clear? This is about the hydrogens. You see hydrogens here 2 and here 2 4, but here hydrogens are what it is 2. This is in the same way balance. This is concentrate. In the same way balance the equation, and here HNO3 and plus H2SO4. Clear ma? So you have to, this is also converted into Fe2SO4 thrice plus what it is ma here 2, you have to take NO plus what it is ma H2. Simple. There is concentrate means here NO2 will be there. Dilute means you will get NO. Clear ma? Balance this equation also, and here 2 irons are there, irons here plus 2, you know here plus 3, how many units increased here? 2 units increased here, and this is a plus 5 and this is plus 2, how many units decreased here? 3 units. Multiply this one with the 3 and this one with the 2. 3 means it is a 6, it is multiplied with the 2. Clear ma? Then you see what you will get. Means you should not by heart this balancing, easy this is. Clear ma? So now balancing equation now. So how many sulfur iron atoms are there? Totally 6 are there, so I have to multiply this one with the 3. Clear ma? So now how many nitrogen atoms are there? 2, so that's why I have to multiply this one with the 2. So how many sulfates are there? 3 into 3 9, but here how many there? 6 are there, 6SO4, so that's why I have to multiply this one with the 3. Then hydrogens, you see hydrogens how many ma? 2 plus 6 8, so multiply this one 4. This is clear ma? So this is about how and oxidation of compounds by the both the concentrate HNO3 and dilute HNO3. It oxidizes hydrogen sulfide to sulfur and sulfur dioxide to sulfuric acid and iron ferrous sulfate to ferric sulfate. This is about the oxidation of the compounds by the concentrate HNO3 and also dilute HNO3. Balancing how it is I already mentioned, very easy. Just if you are means I done very fast. If you want you can go through the redox reactions. There we have it is there how to balance the reactions by using the ionic method. Clear ma? So now action on metal, how this concentrate HNO3 and dilute HNO3 so reacts with the metals. Clear ma? So you already know that here almost concentrate HNO3, clear ma? It attacks all the metals except the noble metals. What are the noble metals here? Platinum and gold. Clear? And with except this, and he concentrate HNO3 will react almost with all the metals. But the products formation, it depends upon the very important, it is nature of the metal and concentration of the solution. And next one is here temperature, concentration of the solution, and next one is what it is ma? Temperature. Clear? So what is that one? You see, first of all here metals are divided into 2 types. So if you see the redox reactions, if you might have studied redox reactions, clear ma? There electrochemical series we have discussed, and we will also discuss the same thing in the electrochemistry. So that chapter is not yet started. Clear? And in that one metals are there, metals are divided into 2 types. Like here hydrogen will be there in the middle, above the hydrogen metals and below the hydrogen metals. Clear ma? So metals are means above the hydrogen metals are more reactive and below the hydrogens the metals are less reactive. Clear ma? And first we will discuss here except what it is ma? It concentrate HNO3 will not react with the noble metals. Noble metals means what it is? Platinum and gold. Clear? And here reaction with metal, reaction with metals which are more electropositive, which are what it is ma? More electropositive, which are more electropositive. Clear ma? So this is the heading, reaction with the metals which are more electropositive than hydrogen. Then what it is ma? Here hydrogen. Clear? Means what does it means? And here reaction with the metals which are more reactive. Clear ma? Highly reactive metals. I said hydrogens, above the hydrogen metals are there, and those metals are highly reactive, like sodium, potassium, iron, zinc. Clear ma? Chromium, lead, all these are highly reactive metals compared to the hydrogen. That means above the hydrogens these metals will be there, so those are very highly reactive. And those reactive metals when reacted with the HNO3, and which type of products it will get. Clear ma? So very important first point is here. Clear? So the first point, mainly only magnesium and manganese. Clear ma? Liberate the hydrogen with HNO3. Remaining metals, clear ma? So it liberates the hydrogen gas. Clear ma? So now see the reaction. Mg is there, and what it is ma here? HNO3. So what you will get here? MgNO3 twice. Clear ma? So what you will get? Take the 2 moles, you will get the hydrogen gas. In the same way, if you take the manganese and take 2 HNO3 and gives the MnNO3 twice, plus what gas will be released? Hydrogen gas. Clear ma? So next one, if I take here other metals, mainly what it is ma here? Zinc. Clear ma? Very important reaction this is for your PU examination. Clear ma? So PU examination very important. Clear? Zinc. If you take the zinc and concentrate HNO3, same previous dilute HNO3, now what it is here? Concentrate HNO3. Concentrate HNO3, you will get the compound is zinc nitrate. Clear ma? Plus this is concentrate. Take here concentrate. Means what is the another product ma here? NO2 plus what it is ma? H2O. Clear ma? So balancing I already mentioned how to balance this is clear. And 0 2, here what it is ma? Plus 2. And here plus 5. And here already what you will get ma here? Plus 5 means here there will be a plus 4. 1 unit decrease here, 2 units increase here. So that's why I have to multiply this one with the 2, means automatically I have to multiply this one also with the 2. Clear ma? So then what you will get here, see this side how many nitrogens are there? 2 nitrogens, and here 2 nitrogens, totally 4. But this side how many nitrogens are there? 1. So that's why you have to multiply this one with the 2, then it become a 4. Both the side balancing equation. Balance the equation. Clear ma? This is with concentrated HNO3. And with dilute HNO3, this is important. Dilute HNO3. Till now we discussed dilute HNO3, if you take, we will get what it is ma? NO, but here different compound you will get. That's why I said, and what the product you will get, it depends upon the nature of the metal and concentration of HNO3. We are taking dilute or concentrated, or it is all also depends upon the temperature. Clear ma? So you will get here compound is same, zinc nitrate, clear ma, plus N2O plus what it is ma? H2O. What instead of NO, what you are getting? N2O, nitrous oxide. Very very important this is. Clear ma? N2O, not NO. Only with which one? Zinc. Clear ma? Balance here. Here how many units increased here? 2 units increased here. Plus 5, and here it is a plus 1. Plus 5 to what is ma? N2O, if you take it is a plus 1. Plus 5 to plus 1, how many units decreased ma? 4 unit. But it is for 1 nitrogen, but how many nitrogens are there? 2. So that's why you have to multiply this one with the what it is ma? 2, then 8. Clear ma? Means what I have to do here, units here 5 to 4 means 8 units here increased, decreased, and 2 units here increased. So that's why I have to multiply this one with the what it is ma? 4. If I multiply this one with the 4, then what you will get ma? 8. So that's why I will write here 4. Clear ma? Then balance here nitrogen. 2 nitrogens are there, 4 into 2, 8. 8 plus 2, 10. So that's why here you have to multiply this one with the 10. Then it will be balanced. Hydrogens 10 are there. So that's why you have to take the 5 H2O. This is with the what it is ma? Dilute HNO3 and concentrate HNO3. Clear? Except what it is here, only zinc. If you take remaining, this is important, very very important. If I take here simply by taking the what it is, take the lead also. Lead you can take it easily gives the nitric acid. Suppose same, take the lead here, concentrate HNO3, I will write directly. Only exceptional case is with this, concentrate HNO3, you know, PbNO3 twice plus NO2 plus what it is ma, H2O. Clear ma? Same, this is with what it is, concentrate. NO2 I mentioned means concentrate. In the same Pb and HNO3, take the which one ma, dilute here. Same, what the compound you will get, PbNO3 twice plus NO plus H2O. Only difference where, here only the difference with the zinc, remaining same. Balance you already know, it is plus 2 increase here, 0 2 plus 2. I will not here plus here unit plus 5 plus 4, 1 unit here, 2 units. Multiply this one with the 2. If I multiply this one with the 2, I have to multiply this one with the 2 also. So how many nitrogen atoms are there? 2 and 2 4, means I have to multiply this one with the 2, then become a 4. Here also take, it is what it is man, plus 2 0 2, 2 units increased here, plus 5 2 plus 3, how many plus 2, how many units increased here, 3, means I have to multiply this one with the 3 and I have to multiply this one with the 2. Then balance here, 3 Pb are there, 2 NO are there, I have to multiply this one with the 2. Clear? So then how many nitrogens are there? 2 into 3 6 plus 2 8, 8 means I have to multiply this one with the 8. This is about the what it is ma, and how are HNO3, concentrate HNO3 and dilute HNO3 reacted with the highly reactive metals.